So let's solve this problem. At first look, this looks like a very complex, difficult problem, question, because this will change its direction due to the gravity, as you know, and it will hit here, it will change its direction, and it will hit the upper ball, and etc. Yes, it will continue. So it will change its direction several times, and how many times also unknown. So if you think in this way, it looks like very difficult question. But we can make it simple. But first of all, let's consider what happens during the collision with one of the walls. Yes. So I will draw it bigger. So let's say it will hit with velocity v1 in this direction, for example. And we know that elastic collision, it means the magnitude of the velocity or speed will not change, only direction will change. So we know that this angle will be equal to this angle, incident angle equal to reflected angle. So velocity will be same, speed will be same, but different directions. Yes. So this is what is happening, or this is a meaning of elastic collision. Let me draw it a little bit in different form. So let me write v1 in terms of components. So it will hit in this direction with v1 cosine theta. It will hit the wall downward with v1 sine theta. So I just did the same thing, just in terms of components. Let me do the same thing here with reflected velocity. So in this direction, v1 cosine theta. This direction, let's call vertical direction, v1 sine theta. So from here, we can understand one thing. So velocity, horizontal velocity or velocity in this direction before collision, it was upward, as you see. This is the value. After collision, same direction, same value. So what we can conclude here, we can say that here we have a collision, it's changing its direction, yes, but velocity in this direction, x direction, let's call, or horizontal direction, it will not change. Direction same numerical value. So basically we can say, we can assume that it's not colliding, or it's not hitting the ball. Actually, it's hitting the wall, but it's not affecting the velocity in this direction, which is very good for us, because now we don't need to know the number of collision when we consider velocity in this direction. So I will use this method. So this is a distance L, and let me assume this is our x direction and this is our y direction. And since we have x and y in this direction, so it's better to write our velocity in terms of these components. So velocity in this direction will be equal to, so here is alpha, it means this is alpha, it means here in this direction we have a v0 cosine alpha. In this direction we have a velocity v0 sine alpha. And we have a gravity downward, so let's write it in terms of components. So in x direction, g sine alpha, in this direction we have a g cosine alpha. So now we can redraw our picture, or we can rotate it. So basically we have this kind of motion with this kind of picture. This is the L distance. In this direction we have initial velocity v0 cosine alpha, if I'm not mistaken. Yes, downward initial velocity v0 sine alpha. In this direction we have a g sine alpha, downward we have a g cosine alpha. Yes. So yes, it's likely it's hitting the ball so many times, number of collision we don't know, but we just proved that this collision will not affect to the velocity in this direction, yes, in x direction. That's why we can write this equation, distance in x direction, so this is our x and y, yes, equal to initial velocity in x direction, which is v0 cosine alpha times time minus 1 over 2 g sine alpha t square. Here we have a negative sign because g sine alpha is opposite to the x. So in this equation, if you pay attention, we have only one unknown, only time is unknown, so we can solve it. So further is just total mass. So let's solve it. Let me multiply by 2 all sides and divide by g sine alpha. So quadratic equation, we have two possible answers. So we can remove 2 from all sides. Here we have a 2, yes. Plus or minus. So now in terms of mass, we have two correct answers. Now in terms of physics, we should decide which one to choose. Or maybe we can accept both of them, but we should be able to explain it. So physically, both answers we can accept because we have a velocity to the right, we have acceleration to the left. It means this velocity will decrease and it will be 0 after some point, yes. Then we have still gravity acceleration in this direction, so it will accelerate backward again. It means it will pass this position 2 times, when it will be moving to the right, then when it will be coming back. But the problem is here, after leaving the tube, it will leave the tube with different angle, yes, a different angle, so it will not come back because we have another acceleration downward, as you see, so it will change its direction, so it will not come back. That's why we need to accept the minimum time, so the smallest time, let's say, which is minus sign. So we need to accept minus sign, we can not accept plus sign here. We need to remove because it cannot come back, because we have other forces, so it will change its direction. It cannot come back exactly to the same tube, yes, because if you remember, tube is like this, so it will leave and it will change its direction. So we need to accept only negative sign, the smallest value for time. But there is a condition for this problem. We don't have any numbers, just symbols. So condition is this particle should reach this point. It may not reach if you have a small velocity. It may hit like this and come back, yes. So that's why we should make sure that it can reach the second end. What is the condition? So at least its velocity here at this level should be equal to 0, at least. Yes, so it's entering with initial this velocity. In opposite direction we have a g sine alpha, and after L distance its velocity should be at least equal to 0, at least. So this velocity should be enough to reach this final L distance. So I will use this equation, final velocity square initial velocity square plus minus 2ax. So I will use it for this problem. Final velocity 0, of course in x direction, yes. 0 initial velocity v0 cosine alpha square minus, because acceleration is negative, sine alpha times L. So from here we see that v0 equal to root 2 g L sine alpha divided by cosine alpha. So velocity should be equal to this one, at least, in order to reach the end of the tube. Yes. So if we have this value, if velocity initial v0 equal to bigger than this value, then our answer will be this one. It will reach the end. Yes, because this solution is when it reaches the end, the second end. So what if initial velocity is smaller than this value? Then it will leave the tube, but from the left side, not from the right side, it means. So it will enter with v0 cosine alpha. We have a g sine alpha here. So this is the length of the tube, L, but it will stop somewhere here, not getting to the right end. So it will come back. So in this case, what we can do, it means we can use this equation, at. So final velocity here, somewhere here in the tube, will be 0. Initial velocity in x direction, of course, minus g sine alpha t. From here, time equal to v0 cosine alpha divided by g sine alpha. So this is the time when velocity becomes 0. So it will come back. It will move downward with the same acceleration. So we need to just multiply by 2. After this time, it will leave the left side. If you have a small velocity, let's say, if you have enough velocity, it will leave the right side after this time.